Chapter 9, Section 9, Combining Functions. Given two functions, f of x and g of x, you can form new functions, either by adding the two of them together or subtracting them. Now I know you're familiar with function notation, f of x and g of x, or at least you've seen it before. This is how you show combined functions. So they put f plus g, and both of them have a variable of x, so that's why it just has the x right there. And this is f minus g, then their variable for both of them is x. So let's practice this. There are reasons in higher math you'll see this comes in handy. This tells us to do f plus g. I recommend writing f and g in their own set of parentheses. That'll help especially when we do subtraction. So I'm going to say f, which is x squared plus 3x minus 7, plus g, which is x minus 5. Once you write that, it's really very similar to stuff we did back in Chapter 8, where we were combining, adding, and subtracting polynomials. We look for like terms. This is the only x squared, so we just write x squared. 3x plus 1x is 4x. Then negative 7 plus negative 5 is negative 12. Okay, on this one, same two functions, but we're going to subtract. This is where I think the parentheses are especially helpful, but I think just getting into the habit of doing it all the time can help. So I would recommend you just drop these parentheses on the first one because they actually don't do anything. But then here, we only drop them after we apply the minus to both of them. So we have minus x minus negative 5, which is really plus 5. This is the only x squared, so it just stays as it is. Positive 3x minus 1x is positive 2x. Negative 7 plus 5 is minus 2. Okay, example 2. Same process. You can see it's still f plus g and f minus g. We're just doing it with new functions. So f is 4 to the x plus 1. This is an exponential. When you have a number raised to a variable, that's called an exponential. We add to that 5x squared plus x minus 1. Well, 4 to the x doesn't have a like term. There's no other exponential in here at all. So we just leave that as it is. We have a plus 1 here and a minus 1 here, so they just cancel out. That leaves us with plus 5x squared plus x. Now f minus g, we'll write 4 to the x plus 1 minus 5x squared plus x minus 1. Just like we did in the first example, I just dropped the parentheses for the first set. But on the second set, we got to make sure we apply this minus. So it's minus 5x squared minus x minus negative 1 is plus 1. So this is the only 4 to the x. This time we have 1 plus 1, so it's going to be plus 2. I'm going to stick it back here just to... This isn't really standard form. You know what? I'm not going to do that. I don't want it confusing. So we'll just say 4 to the x. 1 plus 1 is 2. Then there's no other squared terms. We just write that as it is. There's no other x terms. We just write that as it is. Okay, next example. Not only can we add and subtract, but we can multiply. So if you look, that's what this part is talking about. Sorry about that. Let me see if I get this to focus better. Oh, much better. Okay. So you just have to pay attention to which ones they ask for, though, because we have three functions this time, f, g, and h. So they first just tell us to multiply f times g. And again, you want to use parentheses because you're going to have to do some distributing and or some foiling and things like that to be able to multiply these. So remember, when we have a 2 by a 3, we've got to recall that everything in the first set of parentheses has to be multiplied by everything in the second set of parentheses. So I'll begin by multiplying everything by 3x. 3 times 4 is 12. X times x squared is x cubed. 3 times 5 is 15. X times x is x squared. And then 3x times negative 1 is negative 3x. So that covers everything that's being multiplied by 3x. Now I need to multiply everything in this parenthesis by negative 2. So we treat that minus like it's a negative. So negative 2 times 4x squared is negative 8x squared. Negative 2 times 5 is negative 10, and we keep the x. Negative 2 times negative 1 is positive 2. So I'll pause there because I want to make sure you're able to follow through with all that. After that, we combine the like terms. This is the only cube, so we leave it as 12x cubed. We have 15x squared minus 8x squared, which gives us 7x squared. Negative 3x minus 10x is negative 13x. And then we have a constant, so we write plus 2. Okay, for B, we want to do f times h. So f is 3x minus 2. H is 8 to the x plus x. Again, this is an exponential, so it works very differently than the powers and the polynomials we see. This one is a FOIL because we have a binomial times a binomial, 2 pieces times 2 pieces. So we do the firsts. 3x times 8 to the x. 3x times x is 3x squared. Minus 2 times 8x, we just write it as 2 times 8x because we can't say 2 times 8 because 8 has an exponent applied to it while the 2 does not. And then negative 2 times x is negative 2x. So while I know that looks really different than lots of stuff we do, the good news is we're done because there's no like terms we can combine. So we just circle the answer and move right along. Okay, last one. C is h times g. So I'll let you see it better in just a second, but I'm going to copy it down first. 8 to the x plus x times g, which is 4x squared plus 5x minus 1. Same as we did on part A of this example, we've got to multiply everything in this parenthesis by the first thing. So 8 to the x times 4x squared. I can just write that just the way I said it. 8 to the x times 4x squared. 8 to the x times 5x. 8 to the x times negative 1. So that covers multiplying everything by 8 to the x. Now we multiply everything by x. X times 4x squared is 4x cubed. X times 5x is 5x squared. X times negative 1 is negative 1x. And while this looks pretty clunky, there's no like terms, so we are finished. Okay, last bit we have to know, we've seen how we can add, subtract, and multiply functions. Now we're going to be dealing with the value of functions. So on number 4, it says add f and g, the functions together, then plug in 2. There's nothing wrong with the way this is written, but if it helps you think about it, this is the same thing as saying what's f of 2 plus g of 2. Now it kind of looks like we're distributing the 2. We're technically not, because this isn't multiplying, this is just us using function notation, but it can help clear this out. So to figure out what f plus g is, we need to figure out what f of 2 is. So I look for f of x. I find where x equals 2. Where they meet is negative 4. So if we plug 2 into f of x, we get negative 4. If we plug 2 into g of x, we get negative 5. And negative 4 plus negative 5 is negative 9. For number 5, it's h minus f. So I need to plug negative 4 in for h first. So negative 4 gets plugged in for h, and I get 3, minus plug negative 4 into f. So negative 4 into f is negative 8. So I get a positive 3 times minus a negative 8. So it's really plus 8, which gives us 11. Okay, g plus 5. When we plug in 5, so I need to first plug 5 in for g. So here's 5, here's g, it's equal to 9. Now we need to plug in 5 to f. So I look at 5, look at f of x, plug in 5, and I get 2. 9 plus 2 also equals 11. Now we have f minus h of negative 1. So we need to first plug negative 1 in for f. Here's negative 1. When we plug it into f, we get 5 minus, because of that right there. Now we'll plug negative 1 in for h. So here's negative 1. Here's h. It's also 5. And 5 minus 5 is 0. Finally, we'll use the same idea when we're multiplying. So the beauty here is we really just do each piece individually. We just have to know whether we add the two pieces we find, subtract the two pieces we find, or multiply them. So we're looking at negative 4 for g and h. So here's negative 4. G is equal to negative 3 right there. Look at h. H is equal to positive 3 right there. 3 times negative 3 is negative 9. And our last one, f times g with 2 plugged in. So we look at 2. So just make sure it's clear. I'm looking at this row. And it says plug it into f first. Here's f. When I plug in 2, the result is negative 4. Here's g. When I plug in the 2, the result is negative 5. Negative 4 times negative 5 is positive 20.